Hi students, today's problem is not so difficult, but you have to be careful for counting something. So as I described before, you have learned how to design your grammar using context-free grammar. But as I said before, some part of the context-free grammar can be extracted into another subset of grammar, and that extraction can be represented as a regular expression. So as a quick setting, so I'll show you the temporary I'll show you the handout of today. So this is your first time to use NeoESPA. So uh, it may be somewhat exciting because your system will automatically check your code. Okay, so let me switch the screen to not to your handout. Sorry. So today you will use NeoESPA, which is a brand new system for improved evaluation system of ESPA. And such a system is sometimes called auto-judge. So it is usually called automatic judging system. So you submit your code, and then your system will so automatic auto judge system, and your system will evaluate it automatically. And in the case of NeoESPA, you have 10 test cases. So for every test cases, you will get 10 points. So eventually you will get 100 points, and others may be evaluated by the human inspector. So currently it supports several programming languages, including C, also C++. C++ is also possible. To use NeoESPA, you should sign up with your student ID at neoespa.busan.ac.kr. So let me just show you, because you need to register it while I am explaining the material. So let me reshare the whole screen. And in the NeoESPA, here is your NeoESPA. Let me log out for that first. And once you'd like to try login button, and there's a small button on the right side, right bottom side, sign up. Okay, just click sign up, and then you should make your ID freely. But this should be used for your real student ID. And password, please remember this password correctly. And your name, you can use Korean here. And your phone number, this phone number is extremely important in such cases that your TA have an emergent connection to you. Okay, so please use your real phone number. Cell phone number is okay. And email address, this is another important message, because once you want to reset your password, your TA will verify you using your email. Okay, and submit. So please do this while I am explaining the material. Then your TA will approve you. So once you approved, um, then you can submit a code to this system. Is this okay? At least 2 audiences should reply. Is this okay to you? Yuhan? Anuzin? Is this okay?
Yep.
Anuzin, you can use your microphone. Okay, I cannot take a look uh, of your chatting screen.
Okay.
Okay. So, Anojin, can you explain what is this grammar?
What grammar?
Yeah, this kind of grammar. You have 7 rules for the grammar.
Okay.
So how many non-terminals it has? No? Yuhan, how many non-terminals this grammar
Who?
has?
No. 2.
2.
Mhm.
Which one is that?
There's
Can
like
you
2.
enumerate them? Anuzin.
Uh-huh. Num and IDs are, I think they're terminals and the others are not terminals.
So ID is a non-terminal.
No, number and ID are terminals and others are not.
Others non-terminals. How many non-terminals?
1, 2, 5. No,
5?
4.
Yeah,
4.
which
The AL,
A, L, N,
and this is T.
T.
E stuff and ST.
This one?
That's an ST, and I don't think the other one is not terminal.
This one?
6 is not terminal, I think, so I guess it's
Yes.
4.
You guess what?
So I guess it's 4 SAALTS.
Yes, that's correct. Anuzin, you're correct. So the non-terminals, it is not intentional, but it is sort. S, A, L, T. So you have 4 non-terminals.
Mhm.
Lecture notes? There will be no lecture note. This is just a handout. So you can find this handout from your NESPA once you approved. And the terminals, as mentioned by Anuzin, num is a terminal and ID is not a terminal. But how about this one? Is this terminal? Opening parentheses and closing parentheses. Johan, how about these things?
Terminal.
So these opening parentheses and closing parentheses are terminals, right? How about epsilon?
Mm, 2.
Is 2 is terminal.
Yeah.
Should I include this? But it is not. Okay, so actually epsilon is not a terminal or non-terminal, so you can just neglect this empty thing. Okay, so epsilon is none of non-terminal and terminal, but it can be considered as a string. So epsilon. So I said before that N union T is sometimes called grammar symbol. It is not intentional, but you may read this not. Okay, but so it is a set of grammar symbols. So you may call this grammar symbols. And it is a string of grammar symbols. Okay, so most of you may have conflicts that epsilon is what? It is not a terminal, it is not a non-terminal, but it is a string. So as you know, the string length is empty. String length is 0, so it is an empty string. Okay? Okay?
네.
Okay, for Anuzin. So
Okay.
you too doesn't understand what is the audience. You should reply. Anuzin and Yuan should reply interactively. Okay.
Okay.
Okay. There's a question, Professor. I forgot what parenthesis means in grammar. It is. I just said that it is a terminal. Okay. It is a terminal symbol here. Ganchulan. You just read that. I just explained here. So explain it again. What? Again for what? It is a terminal symbol. Okay. So, but if you just use another non-terminal symbol for number and ID, then you can use this as what is a good name. N is already used here. So maybe P, this is for P. If you use this P, and this is Q, okay, for another non-terminal, then you have to supply other rules. For P, you are enumerating all the numbers. 0, 1, 2, 3, dot, dot. Q, you can enumerate all the identifiers. A, B, C, dot, dot, dot. Okay? But it is just meaningless because it is an infinite set. Okay? So you can just other rules to make these two things. For example, let me show you here. For other rules, for example, this is just meaningless. This is meaningless. That, and you have to use this. Another rules for P. It may be a sequence of digits. So it can be a digit or a digit list. R. Okay. And the digit may be 0 or 1 if you're considering only two numerous binary digits, and R may be empty and digit and R. So it can be repeatedly 0, 1 or something. Okay. And how about Q? So if you are considering only two alphabets, then what is a good name for an alphabet? Maybe I may be an identifier, and S is here. S is STU. IU. It is very very famous name, and I may be A or B, and your Q may be an empty string or repeated of I. So IQ. Not Q. IU, sorry. I have to erase this. And U should be U. So is this okay for you? So P is for numbers, Q is for identifiers.
Mhm.
Okay. Yuan, is this okay for you?
네, 이해했습니다.
Okay. So in a full context-free grammar, you have to use this these rules, but it is too complex to use some simple rules here. So you can extract this. You can extract this, and you can rename this as a number. You can rename this as an identifier, as a token. And for number rules, you will use regular expressions. So in this case, the number may be, for regular expressions for number, maybe 0 or 1 plus. Okay, or if you do not use this as plus, times here. For an identifier, you may use an A or B star. Okay.
Yep.
So you have two domains. One is for the syntax. The other is for the tokens. These are tokens. So you may consider that tokens are the words, not just a character. So the Gantrolon is asking me that what is the meaning of opening parenthesis? It is a token of a single character. This is another token of a single character. Gantrolon, are you satisfied with this? Okay. So today's problem, actually this syntax is for a scheme. This is a scheme syntax. So as I said before, it is a Polish expression grammar. So when you want to express that addition plus 2, 3 can be used. Okay, so you can use this addition as starting from S, you can derive L, and L is opening parenthesis and T, and closing parenthesis, and T is for S, T here, and as you know, S can be atom, and T can be another ST, and atom can be a number or identifier. Atom can be an identifier, and S can be another atom, and T can be another ST. So I have to use star here. And you can continue that identifier. Atom can be a number, and S can be an atom, and T may be an epsilon. Okay.
Yep.
So finally, identifier, as you know, epsilon is nothing, so it can be erased safely. And as you know, A can be another number. Okay. So you have 5 tokens: opening parenthesis, identifier, number, closing parenthesis. And you know that plus corresponds to the identifier, and number 2 corresponds to this number, and number 3 corresponds to the second number. Okay. So these are called tokens. These are called tokens. So it has 5 tokens here. And some of these things is sometimes called a lexical token or lexeme. Okay. It was already explained in your lecture note. So note that you may use operator symbols such as plus, minus, times, slash, and this is a percent sign for modular operation as a function names, so function identifiers. So these are all included as identifiers here. Also, so you may use 5 logical operators: less than, greater than, less than or equal, greater than or equal. This is not an assignment. It is just an equal. So these 5 is also included as an identifier, okay, as a predicate operations. And assume that the identifier consists of alphanumeric characters. I mean the other identifiers. The other identifiers consist of alphanumeric characters. So you can use if like this. If 2, 3, 4. So this is another identifier. Starting with an alphabet. So where the underscore symbol may be used. So if not may be used. If underscore not is a valid identifier 0, 1, 2. Okay. Still it has this, you know that 1, 2, 3, 4, 5, 6. This has 6 tokens. This has another 6 tokens. 1, 2, 3, 4, 5, 6. Okay. Got it? Okay.
Okay.
How about you, Johan?
Yep.
Okay. Okay, good. So today's problem is reading the characters and catching the tokens from it. So I have to charge my tablet. Sorry, it is for it's taking time. Okay. So I'll explain the today's problem first. So today's problem is counting tokens. Okay, read several scheme expressions and count the number of lexical tokens in them. For example, given the following expressions, you have lexical tokens. This is a lexical token. Okay, single scheme expression. How about this? 1, 2, 3, 4, 5. Okay. How about this one? You may wonder that if it is not minus symbol and 29, no, it is not a valid scheme expression. This is a single lexical token. So the same is true for plus 8. This is a valid single lexical token. So if you really want to use a negate operation, then you have to make a unary expression, 29. Okay, so it has 1, 2, 3, 4 tokens. So your program should return 7 because in this case you are counting 1, 5, and 1, and summing up them is 7. Based on the experiment to make a report, so you can make a report for them. So let me just do this and explain other things, other examples. So this is another example. So you have a single scheme expression. Okay, the total one is a single scheme expression. So you can count the number of tokens here. 1 define is a single token identifier. 2, 3, 4 another identifier, closing parenthesis. So how many tokens? 1, 2, 3, 4, 5, 6. So 6 tokens here. For the second one, second line, opening parenthesis, if 3, 4, 5, 6, 7, 8. So 8 tokens. How about the last one? Opening parenthesis. This is regarded as an identifier 2. X is another identifier. 3, 4, 5, 6. So another 6. So summing up them, it is 20. Okay?
Okay.
Okay. So if it is okay, I'll show you the template code of today. So the template code is just a simple code. It is for, you may count the number of characters, not the number of lexical tokens, and the number of lines using the standard library function get character in C. So in this example, you have 4 variables. The variables of them is C, NOC, NOL. Okay, so you have 3 variables of them, and all of them is initialized as 0. But you know that you are using C as a get character target, so that is a variable for storing a character. But I used int here. So why I used int rather than character? Because of this EUF. So since integer variable is used, since the EUF is in the range of integer type, so you have to compare the character with an integer variable. So just use a character type for the integer. You know that character type, integer type is greater than character type in C. Okay. So once you read a new line, number of line is incremented. So for every reader character, number of characters is incremented, and those values are printed. So let me show you in your WinGW window. Here's WinGW. It seems an error of Zoom, so it is showing active windows only. So let me try this again. Okay. So here you have WinGW, and the previous code is count.c. Count.c.c. Okay, the same code, and it is for good for you to use some empty lines to make it more readable. So let me just compile this. G++, or you can just make count.c. And if you'd like to execute count.c exe in the current folder, you want to try +2, 3 and Control D here. So the number of characters 1, 2, 3, 4, 5, 6, 7. So the valid number of characters is 7, but beware that new line is also counted. Okay, so the new line, number of lines is just 1. So how about count.c again? Count.c.exe with, this is a valid scheme expression. How about +2, 3? So I intentionally use spaces here. And the number of lines is 2, and number of characters is 8 plus 2, so you have 10. And in the first line, you have 3 characters: opening parenthesis, closing parenthesis, and the new line. Okay, so it is 13. Okay, so how about the count.c.exe, and the input is rejected from count.c.c. So number of characters is 281, and the number of lines is 18. Actually, you can use word count, which is a tool in WinGW for counting the number of characters and lines and words from your count C, let's see. Okay, and you can find that number of characters is equal. Sorry, number of characters is equal to here. Number of lines is also equal to 18. So what's this? It is number of words. So you may think that, then can I use this as a lexical token? But to my sorrow, it is not possible. It is not so intelligent tool. So just count this word count plus 2, 3, and Control D, and you know that number of characters is 8, number of line is 1, but word is not 3 actually, it is 5. But it is just using 3 because it is using the white spaces as delimiters. So it is regarded as this is your first word, second word, and third word. Okay, so you cannot reuse this. Anyway, so if you try this with word count plus 2, 3, then it is actually returning 5 for words. Okay, so you have to be alert. You have to be alert that you should count the number of something that should be a valid token. Okay, so let me just change this. So have you all submitted? So what is a good name? Counting tokens. So let me just call this, just copy. How to see, let's see. Do you have any questions up to here? The entity, okay, let's see. No questions. So let me just the entity talk, let's see. So if I'd like to count the number of tokens in number of tokens, NOT, not number of tokens. So if you just want to count the parentheses only, so if it is an opening parenthesis or if it is a closing parenthesis, then you can count number of tokens here. Sorry. NOT here. Okay, so NOC is not needed. This is not needed. Okay, and you'd like to just print the number of tokens. So printf Sandy with a new line and a T, number of tokens. Okay, then you can use this as a valid. So make CNT talk. So CNT talk .exe, and you can enter plus 2, 3. So number of tokens should be 5. Okay, but this returns 2 because it only counts CNT talk exe only counts the parentheses. So if it is this one, it is correct for the parentheses only. Okay, but for other things it is not correct. So you may want to count so let me just modify that CNT talk. Let's see if is this it. So you know what is this it. So is this it, then number of tokens may be incremented. So in order to use is this it, you can include ctype.h. Okay. Then you may also count that make CNT talk I want to test that how to submit to your NeoSPA. So can you find this? Can you find this? Okay, so or maybe the whole screen. Okay, so in the whole screen, I want to submit the CNT talk here. So I want to execute Explorer here. So CNT talk is my current source file. So you want to click your homework and counting token. So you'll take a look, talk count to that PDF. Okay, so this is the same contents of this handout. Okay, so you can find the same contents of it. Control on what are you talking about? Can we assume that there is always? Yes, you may assume that, but it is not important because you are not counting the number of lines. Okay. Anyway, so you want to submit code, and then click Control on. Are you okay for this? So left 5 counting tokens, it is automatically selected for C. So if you select file, so if I change this, how about CNT characters, copy, count, the C as CNT the C. Okay, and you want to just print CNT the C. What's wrong? CNTC, that's C. Okay, so instead of printing all these things, you want to just print printf %d and new line with number of characters. Okay, so this is a very wrong file. Okay, but you can make CNTC the C. Okay, CNTC. So this is working for some simple cases. CNTC does, okay, CNTC.exe. It is working for 1. Okay, Control D. It is not working. So you have to eliminate. the new line. Okay, so you have to skip them. So anyway, let me submit this CNTC.c in your file. So where is my folder? This is my folder. How long? It is too long here. So in C, MSys, here it is, home, again, code. So is this not a code? It seems very wrong location. Okay, then I may use this. Okay, here. Okay, so CNTC, select this and upload. Wow, it is working for one input. Okay, so you may try this as your solution, but it is wrong. Okay, so you have to modify the code to count it correctly. Any questions? All of you have good luck for the first first submission to your NeoSPAM, and see you next Wednesday. Okay? Bye bye. 수고하셨습니다.